Welcome, glad you can make it. We're going to be learning in this video about compositions of transformations, which I will define shortly. The goal is that you're going to be able to find the image of a figure after it undergoes multiple transformations. Now, we've been studying rotations, reflections, and translations so far in this chapter, and whenever we're talking about compositions, we're going to be looking at combinations of those things, quite simply. Well, let's talk about what a composition is. I just kind of alluded to it a little bit, but let's be specific enough. A composition is when two or more transformations are combined to form a single transformation, as you see there. Now, what I'd like to do is show you a quick example of what I mean. You can look at right here where I've got three triangles and I've got some other various items in the picture, and this represents a composition. And in this composition, the pre-image, the original pre-image, is triangle ABC. If you can follow the prime notation, you see exactly why that's the pre-image. And what's occurring here is that triangle ABC is getting rotated first 240 degrees. Now remember, in our textbook, all rotations are counterclockwise, so this is a 240 degree counterclockwise rotation. All right, and so that gave us triangle A prime, B prime, C prime. And then we went through another transformation, went through a reflection. We took the image of the rotation and we reflected it in this line M to get the final image of the composition. All right, so the composition mapped triangle ABC all the way to triangle A double prime, B double prime, C double prime. You see how the prime notation, by the way, is applied to if you have a series of images. All right, one apostrophe means it's the first image, two apostrophes will be the second image, three apostrophes will be the third image, and so forth. All right, there you go. Well, that's an example of a composition. Whenever two or more transformations are combined to form a single transformation. All right, well, let's go ahead and practice with some compositions. Here, it says that the vertices of a triangle ABC are represented by the matrix that you see here. And what I'm wanting you to do is to graph triangle ABC and its image after the following. After it's been reflected in the line y equals x, and then rotated 90 degrees counterclockwise about the origin. Now, I've already graphed triangle ABC for you. You can see the point 25, the point 30, and the point 0, -1. Well, let's go ahead and reflect that in the line y equals x first of all. Now here we're going to apply one of the patterns that we just learned in the previous couple sections. Whenever you reflect a point in the line y equals x, remember you just swap the x and y coordinates. So every xy gets mapped to y, comma x. Now I'm going to go ahead and list the coordinates of that image in a matrix itself. And let's go and do that. So we're switching the x and y coordinates. So the point 25, after the reflection will become 5, 2. Then we would get 0, 3 for B prime, and then -1, 0 for C prime. Go ahead and graph that. All right, so there's the image, the first image in our composition, and this is just after that reflection in the line y equals x. I'm going to erase this in a moment, but just to remind you so that you can see that this worked out, here's the line y equals x. And hopefully seeing that, you can see how the symmetry is between the two triangles exists in relation to that line. Okay, don't want to have too much in the picture though, so I'm going to go ahead and erase that. Now what we're going to do is we're going to take that image and we're going to rotate it 90 degrees about the origin. Now in our previous video, we learned the patterns for 90 degree, well, for rotations about the origin period, for 90, 180, and 270 degrees. Now, if you recall, what happens whenever you rotate a point 90 degrees about the origin is that you switch the order of the x and y coordinates, but you use the opposite of the y coordinate. All right, so we'll put y then x, but we're going to use the opposite of the y value that we begin with. So let's figure out what the coordinates of the final image of this composition are. All right, to follow this pattern, we're going to put the opposite of the y coordinate for a point first, so we'll put a -2 there, and then we'll write the x coordinate second. Okay, opposite of the y coordinate first, then the x coordinate second. Opposite of the y-coordinate first, then the x-coordinate second. All right, so these are going to be the vertices of our final image. And let me go ahead and graph that. And so there you see the final image. First, we got the blue triangle there after that reflection of y equals x. Then if you rotate that 90 degrees about the origin, here you get this orange triangle right there. So composition is a pretty simple concept, right? I want to discuss this example a little bit further. I want to do it in the context of this question right here. Does order matter? Whenever you're trying to perform more than one transformation, is it going to matter, for instance, whether you reflect triangle ABC in the line of y equals x first and then rotate it 90 degrees about the origin? Or could you get the same result if you rotated 90 degrees about the origin and then reflected in the line y equals x? Well, we're going to take that exact same polygon, that same triangle, and we're going to do that. First, we're going to use the rotation, 90 degrees about the origin, then we're going to reflect in the line y equals x. And let's see what happens. Now, applying the same pattern that we just did a moment ago, that for 90-degree rotations, you switch the order of x and y, but use the opposite of y. And I will do that with the original triangle ABC this time. So, A prime will be negative 5, 2. B prime will be 0, 3. And C prime will be positive 1, 0. Here's that graph. So there we go. Now let's take that and let's reflect it in the line of y equals x by switching its x and y coordinates, which would give us 2, negative 5 for A double prime, 3, 0 for B double prime, and 0, 1 for C double prime. And here is that graph. Hopefully you can see that blue and orange triangle are reflections in the line of y equals x. All right. Now the question here was, does the order matter? Does the order of the rotation and reflection matter? Well, look at where our image was when we rotated 90 degrees first and then reflected in the line y equals x, and compare that with the previous example here where we first reflected this triangle in the line y equals x and then rotated that 90 degrees. The final image is in a much different location for each of those transformations, right? So clearly the order of a composition can matter. Now there are times where you can switch the order of the transformations and get exactly the same final image, but most of the time the order of the transformations does matter. And so this is worth noting. The order of the transformations in a composition is important in most cases. Great. So one more idea to discuss with you here. We're talking about compositions, and you understand that's one transformation followed by another. There's a special type of composition that you're going to have to work with, and that special type of composition is something called a glider reflection. And I'd like to explain to you what a glider reflection is, give you a definition, and then I'll talk about this example of a glider reflection and this non-example of a glider reflection down here. What a glider reflection is a composition that involves a translation or a glide. Remember, slide is a translation, and if you're gliding, you can say you're sliding. All right. It's a composition of a translation and a reflection. Although there's a slight bit more to the definition than just that I need to explain to you. And so our definition, a glider reflection is a translation followed by a reflection, and that much I already explained to you, but here's the new caveat that I'm throwing in. The reflection has to be in a line that's parallel to the direction of the translation. Now that last part is going to take a little bit of a description, and that's exactly what this example and non-example down here of a glider reflection is supposed to accomplish. You're going to see that in this first example, I've got a quadrilateral A, B, C, D, and then I've got A prime, B prime, C prime, D prime, and then I've got A double prime, B double prime, C double prime, D double prime. In other words, this is a composition. Here's the first image. Here's the final image of this original pre-image right there. And so think about what kinds of transformations would get you from the first to the second to the third. Well, simply a translation would get you from the pre-image to the first image. So let's say that the translation then is this way, as it is. And then what you're going to notice is that you reflect the first image in this line in order to get the second image. All right? Now, I said that this is an example of a glide reflection because notice that this line is parallel to the way that we translated. We translated horizontally. This is a horizontal line. So since the direction of the translation is parallel with the line of reflection, that makes this a glide reflection. This final result here is a glide reflection of the pre-image. And here's a non-example. You're going to notice here, this is the pre-image, the first image, and the second image again. Now again, we had a translation to begin. We just slid A, B, C, D directly to the right. But then notice that the line of reflection for the second part of this transformation is not parallel to the direction that we translated. It's in fact perpendicular, it turns out, right? That vertical line perpendicular to the horizontal translation that we had. So that means this is not a glide reflection. All right, hopefully that makes sense. Now let's do one more coordinate example here and be done. Giving you the same triangle that we were working with earlier, triangle ABC, and we're still following the same directions. We're going to graph triangle ABC and its image after the following transformations. We're first going to do a translation, and you see the rule for the translation, and whatever we get as a result, we're going to reflect it in the x-axis. So our rule for the translation says subtract 3 from each of the x coordinates. So 2 minus 3 is negative 1, 3 minus 3 is 0, 0 minus 3 is negative 3. And then we're keeping the y coordinates exactly the same. No change there, so they'll remain as 5, 0, negative 1. All right, let's make that graph. So there's that. You can see it is indeed just a translation of the pre-image by 3 units to the left. Translated that 3 units there and there as well. Now let's reflect that in the x-axis. Now you might recall that when you reflect something in the x-axis, that what happens is that you just make the y-coordinate the opposite of what it used to be. So you have the same x-coordinate, but then you get the opposite of the y-coordinate that you started with. All right, so from here, let's keep all the same x-coordinates. And then let's make each y-coordinate the opposite of what it was. And graph. All right, so there's the final image. Now, what I'm trying to get at with this example, because we've already done a composition, is that here's an example of a glide reflection. Because think about which way the translation occurred. The translation simply went directly to the left. All right, there's the vector that mapped A onto A prime. And then look at the line of reflection for the final image compared to that. The line of reflection was parallel to the direction of the translation. So that makes a glide reflection. Now, I'm not going to go into the disorder matter discussion too much here, but I will tell you that in a glide reflection, the order does not matter, actually. Okay, we won't talk about why, but it does not matter if you have a glide reflection. Whether you translate first or reflect first, you'll get the same final image. All right, that's compositions of transformations, actually. Thanks for your attention for everything. It's been a helpful video, I trust. See ya.